Now let's talk about how to graph a quadratic function using its vertex, axis of symmetry, and intercepts. Okay, so here intercept including x and y intercepts both. So first, let's look at how we know how many x-intercept of quadratic function. Okay, recall in chapter 1, when we learned the quadratic function or quadratic equation, we used discriminant to determine type of solution. Remember that? We say when discriminant greater than 0, and then quadratic function have two unequal real number solution, right, at the time. So now we try to graph the function. What does two unequal real number solution means? Right? Two unequal real number solution. Solution, that means when y equal to 0, right? We're trying to find what x value equals, gonna make the equation equals 0. So that's what they call the solution. So in a graph point of view, actually that refers to the x-intercept, right? Because we're solving x and then when y equals 0. So that's why from the graph, let's talk about x-intercept. Therefore, when discriminant greater than 0, and then we can find two distinct x-intercept. All right. Later, I'm going to show you the graph, what it look like. If the discriminant equals 0, in chapter 1, we say the quadratic equation have two equal real number solution, right? Two equal real number solution. So two equal real number solution, still, that means we have two x-intercept, but they are on top of each other. So that's why we only actually see 1 point. Okay, so on graph, we see one x-intercept. So it touched the x-axis at its vertex instead of cross. Earlier, when we have two distinct x-intercept, actually it cross x-axis in two different places. And when discriminant less than 0, and then the graph has no x-intercepts. So that means the parabola never cross or touch x-axis. Okay, actually the vertex, is above x-axis if parabola open up, and then below the x-axis when parabola open down. Okay, now let's look at the graph, see how we understand the value of discriminant is actually represent the number of x-intercepts on the graph. So this is a discriminant greater than 0 case. Okay, if leading coefficient A is greater than 0, and then parabola open up, right? And then we see the vertex is below x-axis, therefore parabola cross x-axis, okay, in two different places. That's why we see two x-intercepts. If parabola open down, and then that's the situation. Okay, vertex is above x-axis. That's why it's cross x-axis. Okay, we find two x-intercepts. And then discriminant equal to 0 case, that's the vertex right on the x-axis case. Okay, that's parabola open up case. Okay, we see vertex right on x-axis. Okay, that's the double roots case. Okay, so we only see one x-intercept. If parabola open down, okay, it's similar. The vertex right on x-axis. Okay, for discriminant less than 0 case, if parabola open up, vertex is above x-axis. That's why it's never cross or touch x-axis. Okay, if parabola down, that's this kind of situation. Okay, vertex is below x-axis. That's why it never cross or touches x-axis. All right, so the value of discriminant actually is represent how many x-intercept we're able to locate, okay, on the graph of quadratic function. So now let's look at example. Okay, this is the same example we see from the previous video. So we can easily identify A equals -3, B equals 6, C equals 1, okay? And then in the earlier example, we find the vertex already, which is 1, 4, right? We find the vertex, which is 1, 4. So that means the axis of symmetry is x equals 1. So that's the information we already have. Okay, so now use the information from example 2 and the location of x-intercept to graph the function. So now we only need to find x-intercept and y-intercept. Y-intercept is also easy to find, right? Y-intercepts replace x by 0. So this term is 0, 0. So f of 0 equals 1, right? So y-intercept is 0, 1. And then find the x-intercept. We need to use the quadratic formula method, right? Which is x equals -b plus minus square root b squared minus 4ac divided by 2a. Okay, so first we need to evaluate discriminant. B squared minus 4ac equals what? B squared, that's 6 squared, minus 4 times a, which is -3, times c, which is 1. Okay, that's 36 minus 90 become a plus, right? Plus 12. So we got a 48. Okay, 48 is greater than 0. Therefore, we should be able to find 2, right? 2 x-intercept. We should be able to find 2 x-intercepts. All right, so now let's plug it in. -b, that's -6, b equals 6 plus minus square root of 48, right? We already know the value of discriminant. And then divided by 2 times a, 2 times -3. So plus or minus, we need to split up to 2 different operations, right? One use a plus sign, one use minus sign. So -6 plus square root of 48 divided by -6. The other one is -6 minus square root of 48 divided by -6. Okay, and then if you use calculator, right, square root of 48, actually we can simplify as that's 16 times 3, right? 4 square root of 3. Okay, so we got -6 plus 4 square root of 3 over -6. The other one is -6 minus 4 square root of 3 divided by -6. And then if you plug into the calculator, we got approximately -0.15. This one approximately, we got a 2.15. One negative, one positive. All right. So we got 2 x-intercepts. We got a 1 y-intercept. We got a vertex. Okay, we have axis of symmetry. Right? And then we can use symmetrical property find additional points, which is the symmetrical points of y-intercepts. Okay, and then we can use those to do the graph. So let's look at a graph. Set up rectangular coordinates x-axis, y-axis, and then x equals 1. That's this vertical line. Okay, they should be dashed line. So that's axis of symmetry. We know parabola open down, right? And then the vertex is 1, 4. And then x-intercept, -0.150, positive 2.150. Okay, and then the y-intercept is 0, 1. And then according to symmetrical property, okay, if you draw a horizontal line, and then here is 0, axis of symmetry is 1, so the distance between these 2 points is 1 unit, right? Since symmetrical, here should be also 1 unit. That's why 0, move to right hand side 1 unit, move to right hand side another 1 unit. That's why x coordinates of this point should be 2. And then it's a horizontal line, so have the same y coordinates. That's why 2, 1 will be additional points we can find, based on symmetrical property. So that's the y-intercept symmetrical points, which is 2, 1. All right, so now we have 5 points, and then we use smooth curve, okay, and then draw the parabola. So if we can find 2 x-intercepts, which is discriminant value greater than 0 case, okay, and then when do the graph, we need 5 points to graph the parabola, okay, 1 y-intercept, and then 2 x-intercept, and then 1 y-intercept, and then additional points of symmetrical points of y-intercept. Okay, total 5 points to do the graph. If we can only find 1 x-intercept, which is x-intercept and vertex is the same, right? If that is the case, we only use 3 points to do the graph, which is vertex, and then y-intercept, and then additional points of y-intercept. Only use these 3 points to graph. All right, and then domain and the range. Domain is still all real numbers, okay? Domain doesn't change, but the range will change, right? Original square function range is from 0 to positive infinity, but this one, if you look at the parabola open downwards, so it will go to negative infinity, right? But the highest point is 1, is 4. It occurs when x equals 1. So the domain, the range, domain is all real number, okay? Domain is from negative infinity to positive infinity. Infinity always open interval. Range is lowest point is doesn't know, right? It's real small number. So that's negative infinity. And the highest point we know, which is 4. That's the vertex. Okay, y coordinates of vertex, that's the highest points the y can go. Okay, that's why range is from negative infinity to positive 4. And then increasing, decreasing, okay, from negative infinity to 1, function increasing. Okay, increasing 1 is from negative infinity to 1, and the decreasing interval is from 1 to positive infinity. All right, so that's complete this example. And then we have another example. F of x equals x squared minus 6x plus 9. Okay, that's original PowerPoint. So we can use the same process, right, to do the graph. And this one, actually, this is a perfect square, so we can easily see that can write as x minus 3 raised to the second power, right? So what is the vertex? Vertex is 3, 0. Right? This is already written in vertex form. X minus h plus k, remember? So vertex is 3, 0. Or you can use the transformation, okay, from standard f of x equals x squared, and then replace x by x minus 3, right? That's horizontally shifting to the right-hand side 3 units. And then you can also find the same. Vertex is 3, 0. And then since vertex is right on x-axis, that's why, no, this is the x-intercept, right? X-intercept and the vertex is the same. And then y-intercept is 0c, right? Which is 0, 9. Replace x by 0, these two terms canceled, so only have a c. That's why y-intercept is 0, 9 right here. And then based on symmetrical property, here's a 0, and then x equals 3 is the axis of symmetry, right? Because it's a vertical line passing through vertex. So once we find a vertex, we can find the axis of symmetry right away. That's x equal to 3, a vertical line. So here is 0, here's a 3, so that's a 3 units. Symmetrical point, here's another 3 units. So from 0 to right-hand side 3 and another 3. That's why x coordinates is 6. And then horizontal line, y coordinates is 9. And then we use these 3 points to graph the problem. Okay, or if you want to, at the beginning, evaluate b squared minus 4ac, that's fine. You will see that's equal to 0, right? Okay, let's see. A equals 1, b equals negative 6, c equals 9. Okay, we do b squared minus 4ac, that's negative 6 squared minus 4 times 1 times 9. You see 36 minus 36, right? Negative 6 squared is positive 36. And then minus 36, you got a 0. So that's why we know the vertex or x-intercept, okay, should be right on x-axis. All right, so that's why we use 3 points to graph this problem. Domains still are real numbers. The range is the same, right? Horizontal shifting, right? That's x change, doesn't change the y. So domain is still all real numbers, and the range will still the same as square function, is from 0 to positive infinity, because x change, okay, the y should remain the same. Increasing, decreasing, from negative infinity to positive 3. On this interval is function increasing, function decreasing, function decreasing, right? I write the decreasing. And then from 3 to positive infinity, function increasing. Right, down until here, turning points go up. Okay, from negative infinity to 3, function decreasing. From 3 to positive infinity is function increasing. All right, so that's another example. And then the last one, the function is f of x equals 2x squared plus x plus 1. Okay, so let's evaluate discriminant. All right, identify ABC first. A equals 2, B equals 1, C equals 1. So B squared minus 4AC equals 1 squared minus 4 times 2 times 1. So that's 1 minus 8, which is equals negative 7. Okay, negative 7 less than 0. And then because leading coefficient A equals 2 greater than 0, so parabola open up, right? So discriminant less than 0, that means no x-intercepts, right? Parabola doesn't cross or touch x-axis. All right, let's find a vertex. H coordinates equals negative b over 2a, right? That's negative 1 divided by 2 times 2, which is negative 1/2. Okay, so once we find x coordinates, we find axis of symmetry too, which is x equals negative 1/4. And then k, we need to evaluate f of negative 1/4, right? Which is 2 times negative 1/4 squared plus negative 1/4 plus 1. So that will equals 2 times positive 1 over 16, and then minus 1 over 4 plus 1. That's 1 over 8 minus 1 over 4 plus 1, right? That's negative 1 over 8 plus 1, which is positive 7 over 8. So the vertex is negative 1/4, 7 over 8. And the y-intercept is a 0c, right? Y-intercept is a 0, 1. Okay, right here, And then based on symmetrical property, from 0 to negative 1/4, here is a 1/4, and then this should be also 1/4, right? Because symmetrical. So from 0, left hand side 1/4, and the left hand side another 1/4, that's 1/2, right? So that's why it's a negative 1/2. From 0 to the left hand side 1/2, that's why negative 1/2. Y coordinates, it should be remain the same as 1. So that's why we use these 3 points, vertex, y-intercept, and symmetrical points of y-intercept. And then these 3 points, we graph the parabola. Okay? And then domain and the range. Domain, same, all real number. Okay, domain from negative infinity to positive infinity. Quadratic function domain always all real number, no matter what. And then range, this time it will be changed, right? Is from no longer 0 to positive infinity, is what? Smallest value is 1, right? So that's from 1 to positive infinity because parabola open up. So there's no maximum point, right? Minimum point at the vertex, which is 1. Right? We find the range is all about the y. Increasing, decreasing. This part is decreasing, this part increasing. So decreasing is from negative infinity to negative 1/4. Function decreasing, right? This is a turning point. And then increasing is from negative 1/4 to positive infinity. Function increasing. All right.